Okay, we're going to look at inequalities to begin with. And there's a lot to them, so this will be one of our longer sections. But I remember I used to teach high school math, and we learned all of this in Algebra 1. So it shouldn't be anything super strange for you to see. Okay, now when we talked on Monday, one second, let me get it. Okay, we talked about equations and where we had an expression equal an expression. Okay, now we're going to look at inequalities, which is your less than, greater than, less than, equal, greater than, equal symbols. Okay, now when you work with an equal sign, you get one. Later on, I'll show you how you'll get 2 or 3 answers. Okay, inequalities give you an infinite amount of answers. So we have to be very careful how we write our answers when we're working with inequalities so that we can include everything. So there's 2 ways to write your answer. There's set builder notation and there's interval notation. Now, if you're going to be doing any kind of STEM degree, science, technology, engineering, or math, you're going to use a lot of interval notation. Computer programmers, I think, use quite a bit of interval notation. Okay, so set builder can be used to describe almost any set, but especially useful when writing infinite sets, because we're going to have an infinite amount of answers. Okay, for instance, the set of real numbers greater than 2 is written in set builder notation. Okay, so we have a set, so that's why we have the braces, because we're looking at a set of numbers. Okay, and we're going to use just real numbers, so that's why I put an X. Okay, and then those numbers have to be greater than 2, and that's where you get X is greater than 2. Okay, we read that as the set of elements X. So here's your set of elements X such that, okay, such that is that vertical bar, X is greater than 2, and there's your inequality after the such that bar. Okay, when we're working with interval notation, it's just an alternative to set builder. It's a lot less characters, so I think that's why interval notation has become so popular. Okay, we're going to use parentheses for greater than or less than, and we're going to use brackets for greater than, equal, less than, equal. Okay, it's not hard. It just takes a little bit of seeing it a few times to get used to it. So I'm going to show you some easy examples of using both set builder and interval notation. Okay, if an inequality goes to negative infinity, we use a open parenthesis, negative infinity. Okay, that infinity you will find on that I showed you on the math pad. Okay, so when you click on math pad, just look through those until you find the infinity. I think it's under symbols maybe. Okay, and there'll be an infinity symbol for you to use. Okay, and if it's a negative infinity, this parenthesis negative infinity is always on the left. If an inequality goes to positive infinity, we use a positive infinity with a closed parenthesis, and it's always on the right. And notice the positive infinity does not have a plus sign in front of it. And infinity symbols never use the bracket, okay? Because when you go to infinity, you can add one more and get a brand new number. So we always have to use parentheses. All right, here's a set builder notation. The set of elements x such that x is less than 6, okay? Now, the inequality is pointing to the left, so that means on the left, I'm going to go out to negative infinity. So this is going to yield in set builder, or in interval notation, okay, my x is going to negative infinity, so there's my parenthesis, negative infinity, and it stops at the number 6. Okay, notice it's strictly less than. Less than is a closed parenthesis, so that's why I've got a closed parenthesis after the 6. And then the comma just represents all the numbers in between 6 and negative infinity. Okay, because 5 would work, 5 is in there, 5 is less than 6. Negative 1,000 works because negative 1,000 is less than 6. Okay, here's one, the set of elements x such that x has to be greater than or equal to 5. Okay, my inequality points to the right. That's going to positive infinity. So here on the right is my positive infinity. Okay, it stops at the number 5. 5 is on the left because 5 is the smallest it's going to go. But it includes the number 5 because it's greater than equal. Greater than equal denotes a closed bracket. Okay. We're also going to graph that. It's pretty simple to graph. The 5, I'm going to go to the number 5 on the number line, and I'm going to put the closed bracket. And then the rest of the inequality points to the right towards positive infinity, and you're all done. Okay, let's do one more of those and then we'll move on. Write the interval notation and graph the set of elements x such that x is less than or equal to 3. Okay, so will I have a positive or negative infinity? Negative, because my inequalities pointing left. I'll begin on the left, I'll begin with my negative infinity, comma. And where does the interval notation stop? At what number?
3.
3. And will my 3 have a bracket or a parenthesis?
Bracket.
Bracket because of the equal sign underneath. That's how simple it is. Okay, then at the number 3 on the number line, I'm going to put my bracket that points, it opens up towards negative infinity. My arrow goes to the left, and you're all done. Okay, solving inequalities is the same rules that apply for solving equations, okay? So we had those 5 rules. Okay. Same thing's going to apply, except we have we have 3 more properties that happen when we have inequalities. If you are multiplying or dividing each side of the inequality by a negative number, then the inequality symbol is reversed. Not if you add or subtract. only if you multiply or divide by a negative. So here, I am trying to isolate my letter X to get rid of the times -2. I divide both sides by -2, and I get X. 6 divided by -2 is -3, and my inequality I have to flip over. Okay, if your X is to the right, you need to switch the order of the variable and number, and your inequality symbol is reversed. It's easier to read an inequality if your variable is on the left. So if I switch the X and the 2 around, I have to flip the inequality. Because 2 greater than X is harder for your brain to understand. X less than 2 is real easy for your brain to understand. Okay, if the variable is negative, change the sign of each term and the inequality symbol is reversed. Okay, your variables always need to be positive. Okay, so what I'm going to do technically, well, let me do this first. The opposite of -X is positive X. The opposite of +3 is -3. And I have to flip the inequality around. Or if you just go through and change your signs. Okay, it's like multiplying through by a -1. If I multiply through by -1, well, when you multiply by a negative, you got to flip your inequality sign. Okay, on the next page, we're going to actually solve a couple of them. We're going to not only solve them, but we're going to graph them, write the answer in set builder notation, and write the answer in interval notation. And hang on, I'm going to make a note. I want to show you some stuff on WebAssign when we're done with this section. Okay, so again, for interval notation, I've written down the parentheses or brackets that go with the inequalities. Hopefully you won't need to use them. All right, so I want to solve the linear inequality, and I'm going to solve for the letter X. Okay, well, just like we did in section 1.1, I don't have parentheses, I don't distribute. Okay, like terms, I don't have like terms on the left or the right, skip step 2. I don't have an X on both sides, so I skip step 3. Add or subtract the constant. Okay, I'm trying to get the X alone, so I'm going to subtract the 1 from both sides. 2x is less than 7 minus 1 is 6. Now, I subtracted, don't flip the sign. Only when you divide or multiply by a negative. Okay, and then step number 5, multiply or divide the coefficient. My coefficient is 2. And that yields X is less than 6 divided by 2 is 3. So there's your inequality. Okay, I'm going to graph this. Okay, so it's at 3. The inequality points to the left, so my arrow's going to point to the left. Will my 3 be a bracket or a parenthesis?
Parenthesis.
Parenthesis, because it's less than, and the parenthesis always opens up towards whichever way your arrow went. Okay, set builder notation. I've got the set of all elements X such that, and then you just throw your inequality in there. X is less than 3, and don't forget to close your brace. Okay, now, me personally, if I have graphed it, the interval notation is super simple. Because my arrow, is my arrow going to negative infinity or positive infinity? Is my arrow going to negative infinity on the number line or positive infinity?
Negative.
Negative infinity, so that's helpful to know. Okay. Remember, when we do a negative infinity, we always have the parenthesis, and the negative infinity is always on the left. So looking at my graph, I'm going to bring down parenthesis, negative infinity. On the right is my 3 with my parenthesis, and everything in between becomes my comma, and there's your interval notation. I just find it, whether I need the graph or not, it's so much easier for me to graph it and then do interval, but you don't have to unless the directions say you have to. The next one, do I have parentheses? Nope, skip step number 1. I do have variable terms on both sides, so I'm going to have to subtract 2x on both sides. 5x minus 2x is 3x, plus 2, bring down your less than equal 1. Okay, I've got to subtract my 2 on both sides. I'm left with 3x less than equal 1 minus 2 is negative 1. Divide by my coefficient, x is less than or equal to negative 1/3. Now, we just had big storms in Tonkawa, so we've still got thunder and everything rolling through. All right, graphing, bring down your negative 1/3. Okay, does my arrow go to the left or the right? Which way do I draw my arrow on my graph?
Left.
To the left, very good. And will there be a bracket or parenthesis on my graph?
Bracket.
A bracket because of the equal bar, and the bracket will open up towards whichever way your arrow went. Okay, set builder. The set of all elements x such that, just bring down your inequality, x less than equal negative 1/3, close your brace. I think I said parenthesis there, I didn't mean that. And in interval notation, okay, again, I'm at negative infinity on my arrow, so parenthesis negative infinity, comma, and my graph stops at negative 1/3 with the bracket opening up. And if I ever get off the page or go too fast, don't hesitate to let me know. Okay, now we're going to get a little bit more complicated. We're going to look at compound inequalities. These are inequalities joined by the word and, called a conjunction, or the word or, called a disjunction. We'll start with conjunctions first. They're a little bit more difficult to work with. Okay, if you have an inequality that's joined with the word and, you're going to have solutions that have to be true for both inequalities. If you plug in a number, it's got to be true on both of them. Okay? Conjunctions may be written separate. For example, x is greater than -3 and x is less than -3. But notice the word and is in between them. That means a conjunction, and I have to put them together. Okay? Sometimes they're already together. Sometimes you have to put them together. Okay? So if I were to rearrange this first one, kind of doing opposite of what I said here on number 2, if I put the -3 on the left and the x on the right, my inequality flips to less than. And then I have x less than 3. Well, one of the x's in the word and can go away. And I have -3 less than, and there's my x less than 3. Okay, we're going to practice putting them together. So if you're like, okay, that made no sense, don't worry. We'll do a couple of examples and you'll feel better. Okay, when you make a conjunction, the smaller number is always on the left and the larger number is always on the right. Okay? And we'll make sure they are when we do our examples. Okay? So another note, you will never use greater than or greater than equal on a conjunction. Notice mine right now are both less thans. Even though one said greater than, I was able to manipulate it and make both of them less than. So you will only use less than or less than equal when you're working with a conjunction. Okay, now in the box, I hope this makes sense to some people. Okay, if I have A is less than B is less than C, I can write that as A is less than B and B is less than C. Okay, I can split them up. And that's what I did here. I had them split up and I was able to combine them back into one. Okay, so here's an example that says 2 is greater than x and x is greater than 5. I took the first 2 together and then I took the last 2 together. Okay, and then this one I can flip x and 2 and turn it to less than, and x is greater than 5. So somebody give me a number that's less than 2. Any number.
1.
Say that again.
1.
1. 1 is less than 2. And at the same time, is 1 greater than 5?
No.
No. That is a false statement. That's why you can never have greater than symbols, because it'll be false and both of them have to be true at the same time. You can only use less than or less than equal. Okay, that is not part of your homework or quiz or test. This is kind of just a little type of proof that makes you understand why you can only use less than or less than equal. Okay, the next one was with the word or. We have a disjunction. Ors are much easier to work with. The solutions can be either it's true for one or the other. Okay, it's not true for both like conjunctions. Okay, so if I have two separate inequalities separated by the word or, okay, on a disjunction, you never combine together. Okay, we don't have to go through all this purple mess. They always stay written separately. And I didn't do the graph for conjunction. I'll go back to that in a minute. The graph for or most generally looks like, okay, I've got a 3 and a negative 3, but remember, the negative number is on the left and the positive is on the right, or the bigger is on the right, the smaller is on the left, always. Okay, so for my x is less than negative 3, the arrow points to the left, and it's strictly less than, so I have a parenthesis. On the x is greater than 3, okay, the inequality points to the right. It's strictly greater than, so it's a parenthesis that opens up towards the arrow. Okay, so on the word or, normally your graphs go in two separate directions. Now, I could talk about this section for a whole week, but all of mine that I picked go in separate directions. That doesn't always happen, but if you need that, you'll learn it when you do any kind of computer programming or anything, you'll see that again. The graph of conjunctions, okay, I'm going to use my conjunction here. Okay, I've got negative 3 and positive 3. Okay, my x's are all in the middle, so my line is in between the two numbers. They're both strictly less than, so the parentheses are going to open up towards each other because it's only the stuff in between the numbers. Okay, now let's solve some inequalities. Some of them will be conjunctions and some of them will be disjunctions. And then we'll look at the set builder notation and the interval notation. Okay, so number 1, 2x less than 10. I've got an or here. X plus 1 is greater than 9. So I have a disjunction. Okay, solve each inequality separately. The first one I'll divide by 2 and I get x is less than 5, or subtract 1 on both sides and I get x is greater than 9 minus 1 is 8. Okay, graphing that. 5 is smaller, it goes on the left. 8 is larger, it goes on the right. Okay, x less than 5, the inequality points to the left. My arrow will point to the left. Will it be a parenthesis or a bracket?
Parentheses.
Very good. Okay, on the x greater than 8, my inequality points to the right, so my arrow goes to the right. And it will be a parenthesis also opening up. Notice those parentheses always open up towards the arrows. Okay, set builder notation, the set of all elements x such that. And on disjunctions, we never combined, so we just write down what's up here. X is less than 5, or x is greater than 8, close your brace. Okay, I have a note, set builder notation is multiple choice on your WebAssign, but we will look at that for a moment when I get done with this section. Okay, next is interval notation. All right, now, interval notation on disjunctions is rather complicated. Make special note of this. You will see this again. Okay. Now, I have an inequality and I have an inequality, but then in between the two inequalities, I have this rather large gap. Okay. The gap is going to be a U for union. And the union means it's true for either inequality. Then not for both of them, for at least one of them. Okay, so when we do our interval notation, I'm going to do my left-hand one. That's going to negative infinity. So I have my negative infinity, comma, and then it stops at the number 5. It had a parenthesis. My gap here in the middle, I'm going to use my union symbol. And then my inequality on the right, I had an 8 with a parenthesis, and it goes up to positive infinity. So, comma, positive infinity, and it closes. Right, number 2, we have a conjunction. It's an and. Right, so I'm going to solve for x, so I'll divide by 4. X, negative 8 divided by 4 is negative 2. Trick question, do I need to flip my inequality? Yes or no? No. I divided by a positive number. Even though I got a negative answer, I divided by a positive, so I do not flip it. Only when you divide by a negative number. Okay, and then my and. Okay, I'm going to subtract 1 from both sides. Negative 2x is greater than negative 6. Divide by negative 2, and I get x. And negative 6 divided by negative 2 is 3. But I did divide by a negative, so I need to flip my inequality. And now this is a conjunction, so I need to condense it. Okay, here's the easiest way to put it together. Smaller number on the left, larger number on the right. Your x's will always go in the middle. And they don't have the equal bar on the inequalities, so they will both be less than. And you've written your conjunction. Smaller number left, larger number right, x always in the middle. And they were both inequalities without the equal bar, so they're both less than, never greater than on a conjunction. Okay, I'm going to graph my conjunction. So I'm going to bring down my negative 2 on the left and 3 on the right. My x is in the middle, so my line is in the middle. They're both less than, so the parentheses open up towards each other, and there's your graph. Oops. Oh, hang on, I'm sitting still too long, all my lights went out. Hang on, there we go. Okay, set builder notation. Oops, that was a horrible brace. The set of elements X such that, make sure it's written in conjunction form. Don't do the separated with the and. It's got to be in conjunction. -2 less than X less than 3. Oh, and that line, that conjunction line comes out. That's an error on my part. Okay, set or interval notation is super simple on conjunctions. I've got a -2 with the parenthesis on the left. I've got a 3 with the parenthesis on the right. And all that stuff in the middle is your comma. And you're all done with interval notation for conjunctions. Disjunctions, the interval notation's a little bit more complicated. Oops, I'm off the page. Here we go. All right, sometimes you will be given a conjunction, but it's not separated, it's already in conjunction form. Okay? With it's already in conjunction form, you still need to isolate the letter X, but the inequalities split that up into 3 parts. Okay? So I need to get rid of the +5, so I'm going to -5, but I've got to do my -5 on all 3 parts. 12 minus 5 is 7, less than, now I have an isolated X, less than 19 minus 5 is 14. Okay, I'm ready to graph that. 7 on the left, 14 on the right. It's a conjunction, so my graph will be in between. Parentheses or brackets?
Parentheses.
Parentheses, good job. My pencil keeps breaking. Okay, set builder notation, the set of elements X such that, just bring down your conjunction, 7 less than X less than 14. Interval notation, on the left is parentheses 7, on the right is 14 parentheses, and don't forget your comma in the middle. Okay, we've got one more page, a couple of examples, and then I'll be done with this set of notes, and we'll look at Blackboard. Okay, now, on Monday, we did some work with inequalities. Okay, but we had an equal sign, but remember we had to write them twice. One for positive and one for negative, okay? So we're going to have to do the same thing again on our inequalities. We're going to have to write them twice to satisfy the positive and the negative, okay? So my first example is absolute value. Notice I have greater than or equal to 3, okay? Looking at your original inequality, if it's greater than or greater than equal, it is an OR problem. So your graph should probably go 2 separate directions. Okay? You'll need that information when you take your test. So make sure you know where to find that information quickly. The second example, the original inequality is less than equal. Okay? Less than or less than equal is an and. Most likely Your graph will be in between your parentheses or brackets. You could have brackets here. Okay, ors with greater than equal go separate. Okay, now this is silly, but this is how I remember. Okay, less than and greater than. Less than is smaller. It begins an A. Greater than is an O. A is less than O on the number line. It's silly, but that's how I remember it. Because if it's something you need to use, you're not going to want to look it up the rest of your life. And that's my silly way of remembering it. A comes before O. A is less than O. A is the less than. A is and. Okay, so let's work these examples. Okay. When you have inequality and you have to write twice, the first time, just leave the bars off. 2x plus 5 is greater than or equal to 3. The second time you write it, leave the bars off. 2x plus 5. You're going to flip your inequality to less than equal. And you're going to change the sign of your constant. It becomes a -3. Flip the inequality and change the sign. Okay? It was greater than equal. Greater than equal means that this is an OR problem. It's very important that you remember or know that that's an OR problem. And now let's simplify our inequalities. Subtract 5 on both sides. 2x is greater than or equal. 3 minus 5 is -2. Divide by 2. X is greater than or equal to -1. Or, on the second one, subtract 5. 2x is less than or equal. They're both negative. Just add them up. You get -8. Divide by 2. And x is less than or equal to -4. Okay, we're going to graph it. Now remember, smaller number on the left. -4 is smaller than -1. So on x is less than or equal -4, the inequality points to the left. Bracket or parenthesis at -4?
Bracket.
Very good. And that is a -4. It's gonna, okay. X is greater than or equal -1. Greater than points to the right. We got that equal bar underneath, so we have another bracket. Just like parentheses, brackets open up towards your arrow. Okay. Set builder notation. The set of elements X such that, because it's OR, we don't smash anything together. I have x greater than or equal -1 or x less than or equal -4. Now, on your WebAssign, these two inequalities may or may not be flipped, but they won't give you one like this and then another one where they're flipped and you're like, oh, which one do I pick? Okay, that will be multiple choice on your WebAssign. And then interval notation. Remember, this is the special because it's an OR. We have to use that union. Okay, so -infinity starts me out. Parenthesis -infinity, comma. We stop at 4 with the, or excuse me, -4 with a bracket. Okay, here's my gap. My gap is denoted by the union symbol, bracket -1, comma, and we're going out to positive infinity, and it has a parenthesis on the right. Oh, and if you ever see me make a mistake, please interrupt me and let me know, okay? I love math, but I'm human and I make mistakes, so stop me and point it out if I make one. Okay, the next one was less than or equal, so that was an and problem. Okay, the first time, all we do is leave off the absolute value bars. 5 minus 2x less than equals 7. The second time around, leave off the bars. 5 minus 2x. Flip your inequality and change your positive 7 to negative 7. Okay, solving them subtract 5 on both sides. That 2x is negative, don't forget the sign to the left. Less than equals 7 minus 5 is 2. Divide by negative 2x. 2 divided by negative 2 is negative 1, but I divided by a negative, so I need to flip my inequality. Second equation, subtract 5. Negative 2x greater than equal. They're both negative. 7 and 5 make negative 12. Divide by negative 2. And I have x. Negative 12 divided by negative 2 is 6. And flip your inequality because we divided by a negative. All right, we're ready to graph. Negative 1 is smaller, 6 is larger. Okay. X is greater than equal negative 1. It's going to point to the right. And there'll be a bracket because of the equal bar underneath. X is less than negative 6, points to the left. Or positive 6, excuse me. There will be a bracket. And sure enough, the and is what's in between, which is what we said should happen when you're working with conjunctions. Okay, set builder notation, the set of elements x such that, okay, I had negative 1 with the bracket, so negative 1. The x is in the middle, 6 is on the right, okay? Because they're brackets. Remember, on conjunctions, you can only have less than or less than equal, okay? Because they're both brackets, they're both going to be less than equal, and then close your brace. However you need to look at it to figure it out, I've given you several ways to look at it. Okay, interval notation, super simple. Bring down the bracket negative 1. Bring down the 6 in the bracket. All your stuff inside is the comma, and you're all done. Let's see, let me get back to, let me do it this way. Okay, I'm going to go to, everybody got that written down? I'm going to go to my computer. I want to show you let's see if I can get into web assignment. Even though it says registration, you still click there today to get into your web assigns. Let me go to student view. Okay, so my 1513. Okay, this was section 1.5 right here. I just want to show you a couple of things about what to expect. Okay, so the first one here, we're going to solve the inequality. We're going to use set builder notation, and we're also going to graph it. Okay, so if I subtract 6, I've got 15. Divide by 5, I get 3. So it's already got the x such that I just have to put x. And then over here under symbols, no, sets, no, relations, excuse me. Under relations, there's your less than symbol. Under relations, less than symbol. And then it was 3. And then I need to graph it. So down here under graphing, you've got arrow, pin, erase, undo, your trash can. Okay, I don't know if it counted wrong. We're using the braces and parentheses and brackets, so use those. Okay, my inequality is pointing to the left. It will be a parenthesis, so I'll have an open parenthesis at the number 3. Okay, and then I'm going to use my draw pen, and I'm going to draw my arrow to the left, 3 parenthesis, and then submit my answer, and I'm good to go. Okay, so you might, when you click on those, you might have under relations, here's your less than, equal, greater than equal. Okay, same thing's going to happen here. Okay, here's the one of them. It's 2 inequalities with and. Your set builder notation is multiple choice. Now, on this one, you're going to have a negative 19 over 2. Where in the world is negative 19 over 2? Well, 2 goes into 19 9 times, because 2 times 9 is 18. So it's going to be like negative 18. No, that's not right. Negative 9.5. So you'll come over here to negative 9. It's going to be about right here. And you'll have an open parenthesis. Okay. If you have a fraction and you're like, Mrs. Cooper, I've moved it a little bit, it's not working, email me or click the Ask Your Teacher and say, hey, it's not accepting it, but I'm pretty sure I've got it in the right spot. I'll look at your work, and if it is right, it's just being picky, I will give you credit. But if you have your parenthesis way down here, and it's supposed to be way on the left, I won't give you credit. But if you're close and it won't accept it, click Ask Your Teacher, I'll look at that. Okay? Here's another one that's already a conjunction. You'll just subtract 4 from all 3 sides and then divide by 2 on all 3 sides and then graph that conjunction. Here's a disjunction, set builder, separate. Then here's like our last 2 examples. Okay, this will be an and problem, and this one will be an or. And remember, on ors you'll need one of your unions, but you'll have to work it to find which of these. It's either one of these 3 for an and problem, and one of those. So, and remember, on multiple choice, if it's 5 or more, I think you get 3 tries. If there's 4, you get 2 tries. If there's 3 or less, you only get 1 try on your multiple choice answers. Okay, so hopefully that'll help when you get to your web assigns on 1.5. Okay, it's 10 o'clock. Does anybody need to take a 5 or 10 minute break? Okay. And, Jaden, are you still in Tonkawa? Or in Enid?
Yeah.
Oh, you're just working in the dark because the lights go out on you? Or wave your hand, sometimes that helps also. Okay, well, nobody needed a break. We want to just keep on going. All right. We're going to look at two-dimensional, oops, let me get back to my document camera. All right. Again, we've got a section here that I have taught before in Algebra 1 in high school. So you may not remember it, but you have seen this before. We're going to look at the two-dimensional coordinate system, and we're going to do some graphs. But before we get there, we're going to look at the distance formula. Distance formula is used a lot in calculus. So if you're going to be moving on to calculus, if you're taking a business calc, you'll probably see this formula again. Okay, so I have 2 points. Okay, so on my XY plane, somewhere I may randomly have 2 points. Okay, and the distance is how far apart, how many units apart are those. And it's hard to count when you're on a diagonal. Easy when you're horizontal, vertical. So what we do is we take our 2x coordinates and we subtract them. It does not matter which order you go. You can do right to left or left to right. The reason is we square that answer. So if you have negative, it's going to go positive, and if you have positive, it's going to stay positive. Then you take your 2y coordinates and you're going to subtract them. Again, doesn't matter which way you go because you're going to square that answer and you're going to get a positive. And then you're going to add up those two values and take the square root and you'll be done. Okay, then we have the midpoint formula, and the midpoint says between the 2 points, what's that coordinate, x sub midpoint, comma, y sub midpoint, what's that point right in the middle that divides that segment into 2 equal segments? Okay, so you're going to have the same points, okay? You're going to take the x coordinates, but this time you're going to add them instead of subtracting them, and you're going to divide by 2. And then you're going to take the 2y coordinates, and you're going to add them together, and then divide that quantity by 2. All right, so here's a common mistake I see quite often. Distance, you subtract x and y. Midpoint, you add x and y. Keep that straight when you're working on those. All right, so here I am given the coordinate 6, -5, and the coordinate -3, 1. The 6 and the -3 are your x values. The -5 and the -1 are your y values. Okay, with the same coordinates, we're going to find the distance and the midpoint. So my distance. Now, if we were doing a quiz, I would want to see you fill out the distance formula, okay? I would want you to see the square root of our 2x values subtracted quantity squared plus our 2y values subtracted quantity squared. What will I fill in for my x values? Somebody give me the x values.
6 and -3.
6 and -3. So notice I have a minus -3, not a minus 3, but you subtract a negative coordinate. Okay, what's my y values I'll plug in?
-5 and -1.
Good job. And notice it's a minus between the -5 and -1. All right, so now we're ready to simplify. 6 minus -3, 6 plus +3 is 9. Don't forget, I still need to square that. Plus -5 plus 1, -5 plus 1 is quantity -4, and I still need to square that. If you're like, okay, yeah, I had a bad math teacher, and that plus positive, I don't get it. Just on your calculator, plug in -5 minus -1, you'll get the same answer. Okay? Continuing on, 9 squared is 81. -4 squared, 2 negatives make a positive, so you get positive 16. When you square those numbers, whether they're positive or negative, you're going to get a positive answer. Never put a negative once you square it. And then 81 plus 16 is radical 97, and you're all done. That's the distance between these two coordinates, is a radical 97 units. Okay, for my midpoint, okay, now, your midpoint has a parentheses and it has a comma, okay? It is a coordinate answer. Oops, that orange is gone. I don't want that color either. All right, so on your midpoint, I'm going to add up the x's, divide by 2, parenthesis, comma, add up the y's, divide by 2, and I'm going to use the exact same numbers. 6 and -3 for x, -5 and -1 for 2, and then make sure you reduce completely. Six plus -3 is 3 over 2. -5 plus -1 is -6. -6 divided by 2 is -3. And you're all done. Now, on WebAssign, if they've got the box inside the parentheses, you will only put 3/2, comma, -3. If it has a box with nothing, then you'll have to put the parentheses 3/2, comma, -3. I haven't looked at it in so long, I don't remember. If the parentheses are there, only put the numbers separated by a comma. If there's no parentheses, you'll have to put the parentheses inside the box. Okay, a refresher on what they're calling the rectangular coordinate system. I also call it the Cartesian plane. I call it the coordinate plane. And I call it the XY plane. Okay? Whatever one of those three comes out of my mouth is what I say. Okay, your coordinate plane is split up into 4 pieces. The vertical line in the middle is your y-axis. The horizontal line is your x-axis. And then for trig and for calculus, the top left is called your quadrant Roman numeral 1, and then it goes counterclockwise. To the left is quadrant Roman numeral 2, bottom left is quadrant Roman numeral 3, and bottom right is quadrant Roman numeral 4. Bless you. Okay, right in the middle where the x and y plane crisscross, this is called your origin, and its coordinate is 0, 0. And then your x-axis acts as a number line. Okay, positive numbers on the right, negative numbers on the left, just like a number line. And your y-axis, positive numbers go up, negative numbers go down. I kind of think of a thermometer, and that helps me remember. Okay, over here on the left is plotting points. Okay, the A, B, and C, that's just a letter so you can number your points. Okay, remember the first number before the comma, that is your x-coordinate. The number after the comma is your y-coordinate. Positive x's go to the right, negative x's go to the left. Positive y's go up, negative y's go down. And we're going to plot some points in a minute, so I'm not going to actually plot those points. Okay, so let's plot some points here. Now, I know there are easier ways to plot points than doing t-tables, and we'll get to that later, but the directions for this section want us to review plotting points. Okay, so first of all, I have an x and a y. They're both to the invisible 1 exponent. So I know this is linear, it's going to make a diagonal line. Okay, to make it easier to make a t-table and plot, we're going to solve for y. Okay, so I'm going to take my 2x and I'm going to move it to the other side. Or let me show you the long way. 2x plus y equals negative 1. I'm going to subtract 2x on both sides. Y equals negative 2x minus 1. Or if I know I'm just going to move it over to the other side, it just changes it to the opposite sign. Okay? I always put the x before the constant because that's slope-intercept form, and we're going to be doing that later, and it makes life easier. Okay, now I'm solved for y. Okay, I can plug in picked x's. The easiest x's to pick are negative 1, 0, 1. Okay, so I'm going to plug in negative 1 the first time around. Y equals negative 2 times x minus 1, plugging in a negative 1. Negative 2 times negative 1 is 2 minus 1, which is 1. So my y value is 1. Then I'm going to plug in a 0. Y equals negative 2 times 0 minus 1. Negative 2 times 0 is gone. You're left with negative 1. And then I'll plug in a positive 1. Y equals negative 2 times x minus 1. Plug in a 1. Negative 2 times 1 is negative 2 minus 1. Negative 2 plus negative 1 is negative 3. Now technically you only need to plot 2 points, but I'm going to plot all 3. So start at your origin 0, 0. I'm going to go left 1, up 1. Oops, I'm going to put a blue one so you'll know that's where I got that from. Then I'm going to stay at 0. I'm not going to go left or right. I'm going to go down 1. And then I'm going to go back to my origin, go to the right 1 and down 1, 2, 3. And connect those points with the line. And you're all done. Let's see this section. 1 second. I am going to show you that real quick. Okay, looking at the next one, okay, I have 3x squared plus 2y equals negative 4. Because my x is squared, I now have a quadratic, and it's going to make a parabola shape. That's a U-shaped graph. It can go right side up or upside down. We're going to study these more in depth later on. Okay, so I have picked my negative 1, 0, 1. For parabolas, it's also good to include the negative 2 and positive 2. Okay, now, I could solve for y if I wanted to, but I'm going to do it without solving for y and show you how that works. So I'm going to start off with my 3x squared plus 2y equals negative 4. And the first time around, I'm going to plug in a negative 2. And that gives me only the negative 2 is squared because the 3 is not in the parentheses. Okay, there's only the x is squared here. Be careful of that. I get 3 negative 2 squared is positive 4. Plus 2y equals negative 4. 3 times 4 is 12. Plus 2y equals negative 4. Subtract 12. 2y equals negative 16. Divide by 2, and you get y equals 8. Okay, now I'm going to compare that negative 2 with the positive 2. So had I had a positive 2 in the parentheses, well, positive 2 squared is still 4, And by golly, you're going to get the same answer. Okay, so on a parabola, when you have a quadratic, your numbers that are the same in the x but opposite sides, they're going to have the same y value, so you don't have to do math over and over and over again. Okay, so let's check that with the -1. 3 times -1 squared plus 2y equals -4. -1 squared is 1. 3 times 1 plus 2y equals -4. 3 times 1 is just a 3. Subtract 3 on both sides. 2y equals -7. Divide by 2. And y, -7 halves is the same as -3.5. That'll probably make it easier to graph. And had my -1 been a +1, 1 squared is still 1, you're still going to end up with -3.5. Okay, and then the only one left is 0. So I have 3 times 0 squared plus 2y equals -4. 0 squared is 0 times 3 is 0. Divide by 2, and y is going to equal -2. Okay, we'll graph -2, 8. So left 2 and down 1, 2, 3, 4, 5, 6, 7, 8. -1, -1, 2, 3, and then halfway in between. And then stay at 0 and go down 2. Over 1, down 3.5. And then to the right 2 and down 8. And then you have your parabola shape. Okay, notice where the 2 and -2 had the same answer, they're just mirrored images. And the 1 and -1, they're mirrored images.
Why'd you go down 8 if they're +8?
Oh, because they're supposed to be -8. I'm sorry. Thank you so much. Look at that. -16 divided by 2 is -8, not +8. Good job. Okay, the last one, okay, here's the absolute value bars again. Okay, so our absolute value is going to be a V-shaped. Okay, now this one's more difficult to find because I don't know where my vertex is going to be. So the first thing I need to do is find the vertex. So I am going to let y equals 0, and I'm going to leave off the bar. So here's my y. I'm going to let it equal 0, leave off the bars, and I have x plus 3. Subtract 3 on both sides, and I get x equals -3. So when y is 0, x is -3. And that will be the vertex. And over here on X, I have a -3. My Y value was 0. And once you find the vertex, then go 2 numbers larger down and 2 numbers smaller up from your vertex, and it'll make a real nice absolute value graph. I just need to figure out what these Y values are. Okay, so I have Y equals the absolute value of X plus 3. The first time around, I'll plug in -5. Absolute value, -5 plus 3 is -2, and the absolute value of -2 is 2. Y equals the absolute value of -4 plus 3. Go into my next number. Absolute value, -4 plus 3 is -1. The absolute value of -1 is 1. Plug in -2. -2 plus 3 is the absolute value of 1, which is 1. And then absolute value of -1 plus 3 is the absolute value of 2, which is 2. So I'll go through and plot those points. -5, +2, 1, 2, 3, 4, 5, up 2. -4, 1. -3, 0. -2, 1. -1, 2. And there's your absolute value. Okay, now don't turn the page. There's something I want to talk about on this last graph. But let me go to the computer again. Let's see, what are we on? Well, we're on the wrong assignment. Let me go to 2.1. Okay, so midpoints. Okay, so here's some graphing. All right, so this one is linear. Okay, they just want you to graph a couple of points. All right, so hang on, I've got to write this down because 4x plus y equals -3. -4x minus 3. Okay, so I'm going to use the x coordinate 0. So y is going to equal, so I'm going to have the point 0.3, or -3, excuse me. I'm doing some math real quick. -4, so 1 is going to be -7. Let me double check that. Yeah, and then 1. Yeah, okay. So for this one here, there's a couple of ways you can do that. You can go in and actually plot the point, and 0, -3 works. Okay, and notice point 1 came up, and then another point was 1, 7. Okay, and then I'll take my line. Now when you open it up, I've got a ray and a segment. I want the definite line, and then I can click on my points and it'll draw a line. But notice my line is light blue or gray. You got to click on it again to make it black. So I got to go back to my line, make sure it's black, and then you can double check over here. My point is at 0, -3. Let's say, oh man, that was supposed to be a -2. I can go in and change it. Okay, and then my next point was 1, 7, and my line. So I want to make sure I click on my good line and make it black. Come on, make it black. There we go. All right, and then I can, I don't know how to get rid of that 3. Oh, I would have to clear all and start over again. It won't let me just delete 1 point. So you'd have to hit clear all if you messed up. Okay, but double check your work over here and make sure, okay, let me clear all. Another thing you can do is just go straight to your line and click on 0, -3, and then click on 1, 7. Oh, that was 1, -7, excuse me. Okay, and then again, make sure that that blue line's black and you're good to go. Okay. Let's see, and then because the x is squared, that's a parabola, it's just multiple choice, and then your absolute value is going to be a multiple choice. And then we're going to talk about x-intercepts right now. All right, so let me get back to my Zoom link and get back to my document camera. Okay, so before you turn the page, okay, I'm going to use this quadrant 4. And in quadrant 4, I want you to go on the x-axis, go over 1, 2, 3, 4 points and make a dot. And on the y-axis, come down 3 points and make a dot. Okay, on my purple dot here, because the point lands on the x-axis, this is called an x-intercept. Okay? On an x-intercept, when you write that in coordinate form, that was over 4, and I didn't go up and down, so my y is 0, and your y is always 0 on an x-intercept. The y is always 0 on an x-intercept. Because it's on the x-axis, it's nowhere near the y-axis. Okay, on my blue dot that lands on the y-axis, this is called a y-intercept. Okay, its coordinate is I didn't go left and right, and I went down -3, so 0, -3. And on a y-intercept, your x is always 0. All right, now let's look at an example on our last page. Okay, we're going to graph the x and y intercepts. This works best if your equation is in standard form. Standard form is ax plus by equals c, where a, b, and c are integers, either positive or negative numbers. Okay, but if the x and y are on the same side, it's nice to do x and y intercepts because then you don't have to solve for y like we did on the previous page. But just remember, on the x-intercept, the y is always 0, and on the y-intercept, the x is always 0. Okay, so with 3x minus 4y equals 12, let's begin by finding the x-intercept. So that means I'm going to let y equal 0. So in my equation, 3x minus 4 times 0 in place of y equals 12. Negative 4 times 0 is 0. Divide by 3. And you get x equals 4. Okay, so your x-intercept on WebAssign, they want it in coordinate form. X was 4, y was 0, and there's your x-intercept. Oh, take that back. They have the parentheses already. You'll just do 4 comma 0. Okay, but we're only halfway done. Now we need to find the y-intercept. So I'm going to let x equal 0. And I'm going to go back to the original equation. 3 times 0 minus 4y equals 12. 3 times 0 is gone. I'm going to divide both sides by negative 4. 12 divided by negative 4 is negative 3. So for your y-intercept, x was 0, comma, y was negative 3. Okay, now we need to graph that. So I'm going to graph the point 40, 1, 2, 3, 4. Don't go up and down. And then 0, negative 3, don't go left and right, go down 3. Connect those 2 points, and there you've graphed the x and y intercept. Okay, our last one, okay, this is a multiple choice graph, but you'll have to know the x and y intercepts, okay. Now this one, the y is squared but not the x. That means we'll have parabolas that are going to open to the left and the right. When your x is squared, they open up and down, okay. Any engineering people, you'll see a lot of that in calculus. Okay, also, my x is already isolated. Okay, so when I make my XY table, I am going to pick values for y, because then I can plug in my y numbers and solve for x. So negative 2, negative 1, 0, 1, 2. And my 2 and negative 2 will be the same x value. And my negative 1 and 1 will be the same x value. So I'm going to use the 1 and 2 instead of the negatives because I don't like working with negatives. So I'll start with number 2. X equals 1/2 times 2 squared minus 4. And only the y is squared. So x equals 1/2. 2 squared is 4 minus 4. Half of 4 is 2 minus 4 is negative 2. Okay. So my x is negative 2 when y is negative 2 and positive 2. Then I'm going to plug in a 1. X equals 1/2 times 1 squared minus 4. 1 squared is just 1. So 1/2 minus 4 is negative 3 1/2. And it'll also be negative 3.5 on negative 1. And then x equals 1/2 times 0 squared minus 4. And that whole first term is gone because of the 0. And you get x equals negative 4. Okay, and then we're going to plot that. Okay, so negative 4, 0. 1, 2, 3, 4. And then left 3.5. 1, 2, 3 and halfway. 1 is up and negative 1 down. And then go negative 2 and we go up to 2 and down to 2. And there's your sideways parabola. Okay, now let me show you something real quick on the WebAssign, and then we'll talk about this a little bit more. Okay, so here was your x and y intercepts. Oh, this one you're going to need to put in the parentheses when you figure out when on the x-intercept you'll have an x number and the y you'll need parentheses and comma, and then you'll graph it. Okay, here's the one that goes sideways. Okay, since my y is squared, it's got to be one of these two. They also want the x and y intercepts. Okay, now because it's, let me check something real quick. Okay, I think it's going to be the one that opens up to the left, okay, because of the negative. But here's your x-intercept, and then you're going to have a couple of y-intercepts. Now on your two y-intercepts, the smaller y value is in the top. Okay, so you're going to have x is 0 on both of them. And then y is going to be at, well, that's a weird number. That's kind of like in between, okay? But that's going to be a negative something in the top one and a positive something in the bottom. So since that lands in between the tick marks, let me show you how to find that so that you can get the right numbers here. So let me go back to your document camera. This will be the last thing that we do, okay? Now, so here, negative 4, 0, that's on the x-axis. Okay, this is your x-intercept. Okay, I need my y-intercepts. And on my y-intercepts, I have to let x equal 0. Okay, so when I use my original formula, 0 equals 1/2 y squared minus 4, I've got to solve for y. Oops, I'm off the page. There we go. X was 0, solve for y. I'm going to add 4 to both sides. 4 equals 1/2 y squared. Okay, now remember we talked about this on Monday. This is 1/2 times y squared. I've got to multiply by the reciprocal 2 over 1. So that my 2's and 1's will cross reduce, and 2 times 4 gives me 8 equals y squared. Okay, now I got to get rid of the square, so I'm going to square root both sides. And then you're going to have to break out your calculator and do second of the x squared key. Sec is your x squared key here. There's your square root in green. So I hit second x squared. There's your square root. And then we had 8. And that gives you 2 radical 2. You're going to have negative 2 radical 2. Excuse me, I messed up. and positive 2 radical 2. So for your y-intercept, the smaller is going to be negative 2 radical 2 comma 0, and the larger on the bottom is going to be 2 radical 2 comma 0. And then the negative 4, 0 was your x-intercept. I feel like I went 900 miles an hour on that last bit. Anybody want me to explain that again? Okay. If you get alone and you're like, wow, she did talk fast, remember, I'll have the video. You can just fast forward in the video to get to the end and watch that again if you need to. Okay, that takes care of notes for today. Before you jump and run, okay, tomorrow we'll do 2223, and then we'll take a quiz over the 1112 notes. So make sure you have 1112 with you. I would suggest bringing your printouts of your web assigns with your work shown. That'll help also on the quiz. And then we'll be done for the week. And then you don't come to class on Friday, but on Friday, July 7th, the test will open up on WebAssign. It'll be called Unit 1 exam. You get 2 hours to do it, okay? But you only get 2 tries. You don't have to upload or submit anything, okay? But once you open the test, you can't close it and come back. So you can choose to do it on the 7th, the 8th, or the 9th. I would do it definitely after you get all your homework done. And so don't start the test at 10 p.m. on the 9th. You're going to run out of time, okay? And I would start early in the day on the 9th just to be safe, or do it on the 7th and 8th. All that information is on Blackboard. To read up on doing those tests. I believe it's in the syllabus. Okay? Any questions about tomorrow in the quiz or taking your test? Hey, don't leave until I say I'm done, please. Sit down. That's rude. Any other questions? Okay, see y'all tomorrow. Bye-bye.